Hey friends, Mrs. Hill here. Welcome back to Lab C6. Today we're going to be working in a lab to complete the hot liver lab where we talk about physical and chemical changes in the digestive system. So I want you to start out by making sure that you've read through the lab manual, that you understand the difference between physical and chemical changes, and then go ahead and make your hypothesis on your lab manual before we get started. All right, now that you have made your hypothesis, we're going to do a quick equipment check and then go ahead and get started in the lab. I have a test tube rack here with two clean test tubes. I know that they're clean because they're upside down on the rack. I have a large lab thermometer. I have a pair of forceps here. I have a clean paper towel with two pieces of beef liver. I have a timer, and I actually don't have any timers in my room, so I'm going to be using my cell phone today. You're welcome to use your Chromebook. Google has a great stopwatch that you're welcome to use. And then I have my lab manual and a pencil. So now that we're sure we've got everything ready, we're going to go ahead and, oh, I'm sorry, I forgot something in your materials check. In between each station, I have a beaker full of a clear substance, and you can see there that it's labeled H2O2. So make sure that you're being careful with that acid today when you pour. Obviously, we don't want to consume it, and I am wearing my safety goggles to make sure that that acid doesn't get in my eyes as well. So to start out today, I'm going to turn this around, see if I can do this backwards so that you can see it a little better. I am going to turn one of my test tubes right side up in my test tube rack. And procedure part 1 says add enough H2O2 to a test tube to cover the bulb of the thermometer which has been placed inside the test tube. So I'm taking my large lab thermometer. Keep in mind that the bulb of the thermometer is this red part here at the bottom. So we want that to go down inside the test tube. And then I'm going to pour just enough hydrogen peroxide into the test tube to cover that bulb. I want to make sure that we're conserving resources so that other classes are able to do this lab as well. Part 2 of the procedure says to record the temperature of the H2O2 before doing anything. Record this temperature on the 0 minutes section of the data table. So I want to make sure that I'm measuring in degrees Celsius, and if you'll look at sorry, I'm not sure you can see that. If you'll look at the top of the thermometer, you'll see one side is labeled with a C, one side is labeled with an F. That C is for Celsius. So I'm going to take a measurement here at eye level, and it looks like that hydrogen peroxide is 18 degrees Celsius. So I'm going to write that on my data table as my starting measurement. Step 3 in the procedure says to remove the thermometer from the test tube. I'm going to lay it here on my paper towel, and then add a small piece of liver to the test tube. If the liver sticks to the side, push it down with a pencil. I'm actually going to revise that because I don't want to get blood or any germs or bacteria from the liver on my pencil. I'm actually going to use the thermometer to push it down in just a moment. It says, step 5 says, place the thermometer and begin to record temperature every 30 seconds for 6 minutes. So before I put my liver in for step 4, I'm actually going to go ahead and open up my stopwatch on my phone. It's really important as you do this lab that you not pause or stop the stopwatch at any point, and that you not remove the thermometer from the test tube. Once that liver hits the acid, we want to make sure we have absolutely accurate measurements. So I'm going to take my liver here. I'm going to place it inside the test tube, and then I'm going to use my thermometer to push it down, and once that liver hits the acid, I'm going to start my stopwatch. All right, here we go. Now that I've started my stopwatch, I'm going to pay close attention to my time, and I am going to record a measurement every 30 seconds. Oh, look at that. You can already see it bubbling up there. It's fantastic. You may at some point during the lab have trouble reading the thermometer because all of the bubbles in your test tube. That is totally okay. You don't want to pull the thermometer out. You just want to place it towards the edge. I'm at 30 seconds, so I'm reading 27 degrees Celsius. Just want to place it towards the edge of the test tube so it's a little easier to read. Let's see, can y'all see that a little better? When I turn it to that side, you can see it. We're coming up on 1 minute. I am at 27 degrees Celsius again. So I'm going to continue on with this lab, taking measurements every 30 seconds until I reach the 6-minute mark. So I will be back with you in just a moment to share that data. Okay, friends, so at this point you can see that the bubbling has slowed. Actually, the color of the hydrogen peroxide has changed, and it looks like the color of the liver has changed. And if I kind of move it around a little bit, it looks like small pieces of the liver may actually be in the hydrogen peroxide at this point. I don't want to make too many assumptions, but I can see small somethings floating around in the hydrogen peroxide. I can see that the hydrogen peroxide kind of has a pinkish orangish tone to it, and that the liver has more of like a white brown tone. Obviously there's some bubbles here from where it bubbled up in the test tube. And then I also have my data recorded for trial 1 here. Oh, and I've made a mistake. I need to take off that trial 2 because I haven't taken that measurement yet. So you can see in trial 1, I started at 18 degrees Celsius, and I had an increase of 9 degrees Celsius at 30 seconds. We had 27 degrees Celsius. 1 minute was 27 degrees Celsius. 1 minute 30 seconds was 26 degrees. 2 minutes was 26 degrees. 2 minutes 30 seconds was 25 degrees. 3 minutes was 25 degrees. 3 minutes 30 seconds was 25 degrees. 4 minutes was 24 degrees. 4 minutes 30 seconds was 24 degrees. 5 minutes was 24 degrees. 5 minutes 30 seconds was 24 degrees, and 6 minutes was 24 degrees. So I saw a jump in my temperature initially when the liver went in, and then slowly the temperature began to decrease over the remaining minute and 30 seconds of the lab. So I've also recorded here in the second column the changes that occurred at each 30-second interval to my temperature, and I'm ready to go ahead and get started on trial 2. So I'm going to use a clean test tube here. Ideally, I would also clean my thermometer, but for the sake of time, I have a paper towel here. I'm just going to wipe it down. If you have time, ideally, you would actually wash this with soap and water. Step 6 in my procedure says to repeat steps 1 through 5 with a piece of liver the same size as the piece used in trial 1. So I've taken my lab thermometer, placed it in my clean test tube. It says to cover the bulb of the thermometer with the H2O2. So I'm going to pour it in very carefully, try not to waste anything. Get a little hydrogen peroxide in there. Then I am going to record the temperature of the H2O2 at this point, and make sure that you're using Celsius as your unit of measurement. My thermometer is reading 19 degrees Celsius, so fairly similar to last time, just a touch of change. Then in step 3, I'm going to remove the thermometer. I do want to go ahead and ready my stopwatch before I complete step 4, which is to place the liver inside the test tube. I place the liver inside. Have my stopwatch ready. Once the liver hits the acid, I'm going to put in the thermometer, start my stopwatch. So you can see bubbling again inside the test tube. And definitely some change going on there. I'm curious to find out if that's a physical or a chemical change. I'm nearing 30 seconds on my timer, so at eye level I'm going to take a measurement, and it looks like 27 degrees Celsius. Again, if you need to move the thermometer, it's best not to take it out of the acid, but you can see that when you move it to the edge of the container, it's a little easier to read. I'm nearing 1 minute, so I'm going to take another measurement here. Looks like I'm still at 27 degrees Celsius. I'm going to continue to take measurements at every 30-second interval until I reach 6 minutes, and then I'll be right back to share that data with you. Hey friends, so I finished my 6-minute recordings for trial 2, and I just wanted to show you kind of up close a little bit. You can still in trial 2, when I move the liver around, see small particles that are floating in the hydrogen peroxide. It appears that the hydrogen peroxide has changed colors. There was obviously some bubbling that occurred here, and the liver itself seems to have had a bit of a color change. It looks like it has some white markings on it. It's got some holes in the piece of liver. So that's kind of what I've seen, the same observations I've made in both trials. I've also recorded those temperature changes in 30-second intervals. So for trial 2, I started at 19 degrees Celsius. At 1 minute, it was 27 degrees Celsius. At 1 minute, 30 seconds was 27 degrees. 1 minute, 30 seconds was 27 degrees. 2 minutes was 26 degrees. 2 minutes, 30 seconds was 25 degrees. 3 minutes was 25 degrees. 3 minutes, 30 seconds was 25 degrees. 4 minutes was 25 degrees. 4 minutes, 30 seconds was 24 degrees. 5 minutes was 24 degrees. 5 minutes, 30 seconds was 24 degrees. And at 6 minutes, it was also 24 degrees Celsius. And then I've also recorded the changes as well here in the change column. So make sure that when you're recording those changes, you use positive and negative at the front of the number so we know if it was an increase or a decrease in temperature. Now I'm going to take a moment to look through my data table, and I'm actually going to create a double line graph so that I have a visual representation of the data that I have collected today. I also obviously need to do some cleanup. It's important to note that the waste that's in your test tubes cannot go down the sink today. So over by the sinks, there is a waste beaker that I have. Please make sure that all of your waste goes into the waste beakers, and then all of the glassware, the thermometer, and the forceps can be cleaned with soap and water. The paper towel goes into the trash, and then obviously I'm going to wipe everything down really well with a Clorox wipe and wash my hands with soap and water. So I'll be right back with some more information for you after my cleanup. Hey guys, welcome back. As you can see, I have cleaned up all my supplies in the lab, and I'm ready to get started on my data analysis, which this time includes a line graph. I've kind of already started the process here just so you can take a look at it. In the graph here on the x-axis, I have included the time intervals that I stopped at, and then here on the y-axis you can see that I've recorded the temperature in degrees Celsius. I started with 15 degrees Celsius and worked my way up to 30 degrees Celsius. Those numbers may change a little bit for you just depending on the measurements that you have over here in your data table. Once I did that, then I took those temperature measurements at each time interval and I plotted them on the graph and connected them with a line, so you can see very visually that the temperature jotted up really quickly at the beginning of the investigation, and then slowly the temperature has decreased over time. It's really important that you complete both trials on this line graph. So down here at the bottom you have a key, and I'm actually using 2 different colors to complete my line graph. I did trial A in green, so I made sure to document that on my key. And now I'm going to do trial 2 or trial B in blue. And so I'm just going to put those dots on there for you really quick, and then we'll take a look at what that looks like. All right, so you can see now that I've graphed both lines, this data actually overlaps quite a bit. And my measurements were pretty similar in trial 1 and trial 2. That actually tells me that there was a lot of consistency in my investigations, which is incredibly important. As we know, we want to have our results as consistent as possible. That shows that we considered all of the necessary controlled variables. This probably means that my pieces of liver were really similar in size, that I used very similar amounts of the H2O2 acid, and obviously my time intervals were the same, and I used the same thermometer throughout the lab. So I think that this is some great data. At this point, we're going to go ahead and move on to the lab analysis section. So take a look at those questions, think about what you investigated today, and what I want you to think about overall is what is the difference between a physical and chemical change based on the data that we collected, the temperature changes, the color changes, the bubbling up of the acid. Do you think this is a physical or chemical change? And then what evidence do you have to support that conclusion? Once you've gone through all of that, then I want you to think about what this looks like in your digestive system. What part of the digestive system is this representative of? And what sort of digestion is occurring at that point? Is it mechanical digestion or is it chemical digestion? So think through some of those things. We'll continue talking about them in class. I hope you had a lot of fun with today's lab. It's always fun to see that acid bubble up, and just enjoy getting into the lab and getting dirty a little bit. I hope y'all have a great day, and I'll see you in the lab.